Hello everybody, welcome to the first module part B, where we are going to talk about the examples that we had related to our first module. So if you remember, for the first module, we were talking about algebraic foundations, which was about the language of math. We talked a little bit about different kind of concept, for example, different kind of number categorization, about the PEMDAS, about different kind of properties, and etc. So today we are only going to focus on those. For those of you that don't know what's going on, you can obviously go to the previous video, which is about the first module of Algebra 101, and after that you can come back to the video again to completely understand what is going to happen in the next slides. Again, I do have a couple of questions for each slide, and it will be better for all of you to pause the video, think about it a little bit, and after that try to some kind of play the video and compare it with your own answer. So without further ado, let's get it started. So for the first one, we do have about some kind of the numbers categorization check. If you remember, we had different kind of numbers. The first one was natural numbers. We had integers, rational numbers, irrational numbers, and real numbers. So for the very first question is that, is a -3 considered as a rational number? If you remember, the rational number is the one that you can write it down as a fraction. For example, 3/4 is equals to 0.75. So I can consider the 0.75 as a rational number. So at this point, are there any two numbers that I can divide them together, and after that I do have -3? Obviously, right. So I do have -3 divided by 1. I do have 3 divided by -1, and these two numbers can be written and we still have the -3. So we can say yes, this -3 is a rational number. Is 5/4 is an integer? Why or why not? So if you remember, the integer was a number that is going to start from -infinite, and it would be like this: -2, -1, 0, 1, 2, 3, again to positive infinite. So at this point, you see that we do have whole numbers. There's no decimal points, there's nothing. They are just the number itself. So at this point, we cannot say that 5/4 is going to be considered as integer, because if you divide that one, this number, it could be 125. So 1.25 is not going to be considered as any of the categories of this number. So this one is a no. So evaluate the -7, absolute plus 3. What was absolute? If you remember, absolute means that is going to make the number inside of itself as positive. It doesn't matter if that number is negative or positive, it's going to give us positive all the time. So -7, or absolute of -7 is going to be considered as 7. 7 plus 3 is going to be 10. After that, we do have the complete 14 subtracted by -6. So again, we know negative times negative is going to be positive. So I do have 14 plus 6 is equals to be 20. For some of you that maybe have a little bit problem, negative multiplied by negative is going to be positive. Positive multiplied by negative is going to be negative. Negative multiplied by positive multiplied by positive is going to be positive. And negative multiplied by positive still is going to be positive, negative itself. So which skill of PEMDAS or properties that we are going to use in order to find this one? If you remember, what was the PEMDAS? PEMDAS means the order of operation. It means that obviously we do have different kind of operation for each example. At this point, for example, we do have parentheses, we do have addition and subtraction. By using the order of operation, which we know as PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction, we can use it in order to simplify everything, and we know where we should start and where we should end. So at this point, I do have 3 times 2x plus 5. So we know that from the first property, I can get rid of parentheses over here. It means that 3 multiplied by 2x, and after that 3 multiplied by 5. So what do I have over here? I do have 6x plus 15 subtracted by x. So I know these two terms are like terms. Again, about the like terms and unlike terms, about the coefficient and constant, we are going to talk about it in detail in next some kind of modules. Don't worry about it. But right now, I do have two things that are like each other. I have six apples, and I would like to subtract 1 apple from it, so I can do it. So at this point, the simplified version is 5x subtracted by 15, and I cannot go any further because, again, I don't know anything about this equation itself. So for the next example, I do have which concept is going to help me in order to evaluate this one. Again, we are going to use the PEMDAS itself. Since we do have the parentheses, we are going to look inside the parentheses itself. So nothing is happening, it's just negative 3 itself. After that, I do have the multiplication. We know that parentheses, exponents, multiplication, and division, those two, they do have the same order. So at this point, I have to follow the multiplication and goes from left to right. So I do have positive multiplied by negative is going to be a negative number. 6 times 3 is going to be negative 18. So I do have negative 18 plus 4 is going to give me negative 14. After that, evaluate these. So as we all know, the absolute means that any number inside of it is going to be converted to positive. 2, 4 is going to be 6. For the next slide, again, try to pause the video, answer all of the question, and come back to compare your answers with the right ones. So classify 0 as natural, integer, rational, irrational, or real. Again, as you just remember, we had a table in the previous video. So in that table, I talked about it that maybe one number categorized into more than one category. It means that, for instance, 0 can be integer, and it also can be as a rational and also can be as a real number. Why again? Because we know 0 is a number that is going to be inside the integer itself. If you remember, negative 2, negative 1, 0, 1, 2. So it's going to be this one. But again, it cannot be considered as a natural number because natural number starts from 1 and move to the positive infinite. So this is not. Rational number means that we can write down this number as two numbers in the fraction style. So 0 can be written as any number, 0 divided by 6, 0 divided by 7, or 0 divided by anything. So this is a fact. 0 divided by any number is going to be 0. We do have some exceptions like 0 divided by 0, which is going to be undefined. So we're not talking about it. But again, we can write down the 0 as a fraction itself. After that, we do have irrational numbers. So if a number is going to be considered as rational, it cannot be considered as irrational. So those those categories are completely opposite to each other. So it is a rational number, it is not a irrational number, and we know that about the real number means that real one is all rational and irrational number. So if the number is irrational or irrational, is going to still be considered as a real number. Real number is the mother of all of those numbers. So we can say that yes, this number, it can be as real because it is a rational number. Classify the root 2. So we know that root 2 is a number, if you just can some kind of do it in your calculator, that you cannot write it down as two some kind of numbers, one over another one, and as a fraction. So this number cannot be rational again. And if the number is not rational, we can write it as irrational. So again, it's not going to be considered as integer because integer are just whole number and it's not natural one, but still going to be considered as real number. What about 3.25? So 3.25 is not a natural number because it's not a whole number. It's not considered as integer, but it can be considered as a rational because I can find two numbers that if I divide them together, I can have this number itself. For some of you, if you wonder what that number is, the number is going to be 13 over 4. So this 3.25 can be considered as a rational number. So it cannot be irrational and also can be real. What about negative 18? It is easy. It's not going to be considered as natural. Natural is all positive. It's not going to be considered, it's going to be considered as integer. Rational, yes. For example, we can find 18 and negative 1 itself. So it can be as rational. And it also cannot be as irrational, and it can be as the real number itself. The next question, we do have 6 over 7. This 6 over 7 can be a number, so we can write you can use the calculator itself. It's not considered as a natural number, not an integer. It can be considered as a rational because obviously we do have a number out of it. So we are going to consider this guy as a rational one, but cannot be considered as irrational, but still can be considered as a real number itself. You have a very famous number, which is pi. Again, pi is 3.14, and it's right now it has some kind of unlimited number after that. So it means that we cannot write it down as one number over another number. So it cannot be considered as a rational one, but it can be considered as irrational, not integer, not natural, but still can be considered as a real one. So pi is one of those numbers that you can memorize it because all the time it's considered as irrational numbers. So at this point, we do have another question. Which numbers belong to natural numbers? We know natural numbers means that they would start from 1, 2, 3 to positive infinite that is going to increase 1 by 1. So 1 is there, 12 and 17, that's okay. Which numbers are integers? Again, integers are numbers that would start from negative infinite, -3, -2, -1, and also 0 is going to be considered as that, and also positive is going to be all the natural numbers itself. So again, what do we have as integers? So -7 is there, -2 is there, this one is some kind of considered as 2.5 or decimal number, or it's a rational number, we're not going to consider that. 0 is there and 8 is there, so all of them except 5/2. If x is a natural number and x subtracted by 9 is -2, find x. So it's about equation. This whole thing that you have right now is equation. We are going to talk about it in the next module, but right now, just find a number that if you subtract 9 out of it, you got -2. So obviously that number is going to be 7. Why? Because out of 7 you only can subtract 7 out of 9 itself, and after that you have 2 left. 0 subtracted by 2 is going to be -2. Again, don't worry about it, we are going to talk about it in the next slides. So again, we do have another example. If x is an integer and x plus 5 is equals to be 1, find x itself. So obviously that number is going to be 4. We don't have to do any kind of magic over here. What is the next integer after 6? So that the integer is going to be considered as 7. What is the next integer comes before -2? That one is -3. How many integers are there from -4 to 3, including both? So again, we are talking about the integer -4, -3, -2, -1. Don't forget about 0, 2, 1 obviously, and 3. So we do have 4 over here, and if you have another 4, so that would be considered as 8. So find all the natural numbers between 0 and 8. So obviously if we say that between them without including both of them, so it would start 1, 2, 3, 4, 5, 6, and 7. These are the numbers itself. For the next one, we do have again about the rational or irrational, but right now it's going to be a little bit challenging. Why? Because we do have the root or maybe fraction itself. It's not going to give us very some kind of vivid deal, and obviously we have to do a couple of things over that. So let's get started from the first one. What do we have? I do have root 49. So what is root 49? As we all know, root 49 means that root is 7 to the power 2. So this guy considered as the 7 itself. Easy. And if we want to classify that, that number can be considered as integer, can be considered as rational, and can be considered as real one. So what about -15 over 5 is going to be -3. Again, this number can be considered as integer. It cannot be as a natural one. This number can be as the rational number because we can write it down as a fraction, and it also can be it can be considered as real number. 18 divided by 9 is going to be 2. Again, same scenario. So is the square root of 18 is irrational? Why or not? If you find the square root of 18, you can see that it's somehow right the square root of 2. So right now we can say this number is irrational. Again, when we do have this kind of vague numbers or numbers that most of the time has more than 2 decimals, we consider them as irrational numbers. So at this point, when a number is irrational, obviously cannot be considered as rational. What about this number? This number means that 0.27272727 to infinite. So we are going to use this one, use this symbol in order to show this big number. So obviously this number, again, can be considered as a rational number. Why? Because if you find 3 divided by 11, you can see this number. Maybe some of you would say that, okay, this number is not that kind of easy. But yes, you have to know it with practice. But finding the rational number sometimes is going to be challenging and needs lots of practice and see so many examples in order to find that. After that, we do have pi over 2. We know pi is a rational number, so it doesn't matter if you divide it by 2, multiply by 2, or do anything with it. It's still going to be considered as a irrational number, so we do have it as irrational. And after that, we do have sort this ones into rational and irrational. So let's see. So 2 can be considered as rational. Yeah, we do have 2 fractions. Root 7, no, this we cannot. So this one is irrational. So this one and this one. So -1, yes, rational. Oh, -1.5, again, can be considered as rational. 0 rational, this one irrational, and this one is going to be considered as rational. So simple. So after that, we do have the positive and absolute. Just give you a little bit definition of what is happening over here. Opposite means that we do have 2 numbers that the only thing that they are different is their sign. one is positive, another one is negative, while their difference or their distance from themselves to number 0 or the reference is going to be some kind of the same. For example, when we are talking about 7 and negative 7, the only thing that's going to differ one from another is that positive and negative sign. Another thing that we do have about the absolute value, I told you absolute means that the distance of your specific number to 0 without any some kind of consideration of positive or negative as a sign itself. So we do have the absolute. Again, this is the symbol for absolute. Any number inside the absolute is going to be considered as positive. This number we do have inside, we do have as -6. But since this guy is inside the absolute, going to say it as 6. What about this one? We know negative times negative is going to be positive, so we do have -4 plus 11 considered as 7 itself. Absolute plus 7 is going to be 7. What is the opposite of 8? Again, as I told you, the only thing that is going to be considered as a difference between the number and its opposite is just a sign. So this is positive 8. This guy would be -8. What is the opposite of -13? Positive 13. Solve this one. So this question is a little bit challenging. So I do have absolute of x is equals to 6. So what can you understand? There is a number that if that number gets inside that absolute sign is going to be 6. So right now I can ask you that how many numbers that you can think of? So obviously you can think of two numbers. Yes, the very first number is just positive 6 itself, right? Obviously. But the second number actually you can think of is the -6 itself. Why -6? Because as we remember, any number inside the absolute is going to be considered as positive. So it doesn't matter if I have -6 or positive 6, both of them would be 6. So at this point, I can say this number is going to be considered as either -6 or 6 itself. So this question is for some of you that are looking for more some kind of challenging part. You can just comment it down below. But this is going to be about when a term is smaller than equal or another number or term, and if they have the absolute. Again, we are going to talk about it in the future, that how we can combine this kind of expression and terminology with the absolute self. So don't worry about it. But for some of you that are looking for challenges, I really dare you to write down the answer of this question specifically on the comment itself, and I will tell you is it right or not. So let's go for another one. So I do have the distance. Again, the distance is meaning that what is the distance between two values, and we know a formula for that. The distance between any two numbers is absolute of a subtracted by b. So at this point, I do have -5 subtracted by 5 is going to be absolute of -12, which is 12 as absolute value. So at another point, I do have 3.5 subtracted by -2.5. So I do have this one as positive 6, so 6. So we do have a word problem. So sometimes your problems are not going to be only numbers itself. Sometimes they're going to put those numbers inside the word problems, because as someone knows mathematics, as someone as engineer or any other kind of people, they are going to expect you to solve this kind of question. Not all the question again are going to give some numbers, formulation, and bam. Sometimes you have to think about the questions. So for instance, I do have a town is at -12 on a highway, and another one is at +7 of that highway. How far apart are they? So obviously we're talking about distance, right? So -12 subtracted by 7 is going to be -19. Again, absolute doesn't care about the positive or negative, so I do have a positive 19. A bank account goes from $18 to -$6, so obviously go to 18 subtracted by -6. And this guy is going to be considered as absolute of 24, which is 24. Another thing that we have is to find the equation. Again, we are going to talk about it in the future, but I thought it would be better to see a couple of these questions that we would see in the next some kind of modules right now and talk about it. So as you just remember from the previous slide, when I do have this one, for example, this p subtracted by 2 is considered as big P. And I would ask you that big P is equals to 9 itself. So what is the P right now? So obviously you can think about two numbers. The first number is 9 itself, and the second number is -9. So it means that my big P, which is P subtracted by 2, is either 9 or -9. So if I ask you what is the P, if you just solve this one in your head, you have 11. And for this one, you have -7 itself. Again, I'm not expecting you guys to right now to answer this kind of question. Look at the next module. Right now we don't have it, but we are going to record that one in the future, look at the next module, and if you can solve that one, if you can solve all of the questions there, you can again come back over here and solve these questions again. So again, we do have the submarine that moves from negative 150 meters to negative 35. So what is the distance? Negative 150 subtracted by negative 35. I do have this one as positive 35. So this one is going to be negative 115. So it will be 150 meter. Again, this question can be considered as a little bit challenging. Well, so I dare you to answer this question on the comment down below again. So let's move to another one. Again, I do have the PEMDAS. Again, what was the PEMDAS? PEMDAS, or order of operation, means that if you do have different operation in your question, you do have a cheat sheet for yourself that where you should start. Again, P means parentheses, E means exponents, M and D means multiplication and division. They're going to come side by side. The only thing that's going to give them order is that which one comes first when you move from left to right. A and S, which is addition and subtraction, still the same over here. So for this one, let's talk about this question. I do have 8 subtracted by 3 times 2 plus 5. We know that based on the PEMDAS itself that we do have on the top, multiplication comes first. So this one is 6. 8 subtracted by 6 plus 5. So this one considered as 2 plus 5 is going to be 7. So after that, we do have 16 subtracted by 4 plus 7 multiplied by 2. We have to do the multiplication first. After that, we have to do the division. After that, we have to do this addition. 7 times 2, 14. 16 subtracted divided by 4, 4. This guy is going to be 18. So for the next one, we do have 9 plus 3 times 2 to the power 2. First of all, we have to do the exponents. 4. Again, after that, we have to do everything inside the parentheses. I'm sorry, parentheses comes first, but right now it doesn't matter. So 9 plus 3 is going to be 12. 12 times 4 is going to be 48. After that, we do have this one. So we have to do the parentheses first. 7 subtracted by 4, 3 to the power 2 is 9. 5 times 9 is going to be 45. Subtracted by 1 is going to be 44. Then we do have this one. Again, do anything inside your parentheses. 6 subtracted by 3, 2. 8 subtracted by 3 is going to be 5. After that, we have to consider this some kind of exponent. So we do have 25 subtracted by 4 multiplied by 2 is going to be 25. Subtracted by 8 is going to be 17. The next one is going to be a little bit challenging. 6 subtracted by 2 is going to be 4 to the power of 2 is going to be 16. Plus 5 is going to be 21. After that, we do have 2 times 21 itself is going to be 42. Divided by 2 is going to be 21 itself. As you can see over here, first I did the multiplication, then I did the division. The last one is the final boss. I dare you to do this one for me, and after that, put the answer in the comment below. So there's a different kind of common mistake that if you don't know about the PEMDAS and if you don't know where you should start, from left to right, you're obviously going to face that. So let's look at the first one. So it means that I do have 3 plus 4 divided by 2. So what would happen at this point if I some kind of do the addition first and after that do the division? So obviously I'm going to face a problem. Why? Because 3 plus 4 is 7 divided by 2, 3.5. While based on the PEMDAS, I have to do the 4 divided by 2, after that added with 3. So at this point, you just saw the error itself. So another one, I do have 2 times 3 plus 5 to the power 2. Obviously, we have to solve it this way. But imagine that if I don't respect two parentheses and don't consider that, and I just multiply these two together and after that added with 5 plus 2. So you obviously can see where the mess comes from. And another one is 2 plus 3 to the power 2. So we do have it like this. So obviously this is the problem. Why? Because when you have addition and when you have exponents, you cannot do it right now. Why? Because this rule, a plus b to the power 2 is not going to be equal as a to the power 2 plus b to the power 2. We do have another rule that a times b to the power 2 is going to be a to b2, that we talked about it in our some kind of math 101 about the power section. So you can go there, and I had so many examples about that and I explained it completely, so you don't have any problem with it. Anyway, so obviously you saw the problem is. So at this point, I'm going to ask you to this question again. So this is one of those common questions. You see that on YouTube, on Instagram, or just some kind of, they have this kind of interesting titles, say that if you consider yourself as 1%, try to answer this question. So try to find the parentheses and put it there, put it at the right point in order to find the answer, final answer as 7 for yourself. So if you remember, for the last part, we were talking about different kind of rules or properties that we do have it as commutative, associative, and identify, and some kind of apply itself. So for the first one is that name of the property itself. So whenever you have the rule like this, that A plus B is going to be considered as B plus A, we call this rule as commutative property. So the first one has the commutative property. It has a name again. You can memorize that. It would be better to memorize them. The next one is that A plus B plus C, if you consider A and B into parentheses, can be written as A plus B plus C. So this is another rule that we call it as associative property. Regroup to make this one easier to add. Again, you can use the associative property by using either this or this, or even this. It doesn't matter. You can use the rule. Again, we do have the regroup of this one. It means that at this point, I do have A plus B plus C. So I'm going to write it down as A plus B plus C. How can be? It would be -4 plus 7 plus 3. So use the associative property to rewrite this rule and simplify it for this one. So again, it's simple. So we know already that this guy is associative property. So if I consider that A is 2 and B is 5, you just see as 2, just see as 5. 2 plus 5, 7. 7 plus 7 is going to be 14. Remember, when you are using the rules, you have to be careful. At the end, the answer for both of them should be the same. So it doesn't matter if I do it this way or if I do it this way. Still, I do have 2, I do have 5, and my final answer is going to be 14. So rewrite by grouping of 3 and 8 first. So at this point, I do have x plus 3 plus 8. Again, associative. What property allows you to write this one as this one? Again, this one was about the commutative property itself. So after that, we had some kind of rules about the expansion itself. If you remember, it was the first one was about this distributive property. It means that if I do have A times B plus C, I can write it down as A times B plus A times C. This is the way that I can get rid of fraction. AB plus AC. So let's apply it over here. 4 times x plus 4 times 6. 4x plus 24. What about over here? -3 times 20x, -3 times -5. So I have -6x plus 15. And after that, what do I have over here? After that part, I do have what is the additive identity for the 12 itself. So again, what was the additive identity? If you remember, when I was talking about that, a number has two values. The first value, if you add that specific value with the number itself, is going to give you that number itself. And also there is another number that if you multiply that by your number, you're still going to get your number itself. So for instance, when I do have 12 and I would like to find the additive identity, it means that what is a number that if I add it with 12, I'm still going to get 12. So obviously it's 0, right? So at this point, the answer is going to be 0 itself. Find a multiplication identity means that I have to find the number. If I multiply it by this number itself, I'm going to have the 1 as the final answer. So when we are talking about the multiplicative identity, we are talking about the reciprocal. So the only thing that you have to do is find the reciprocal of this number. Again, about the reciprocal is that you have to change the place of numerator and denominator. So I do have this one as my answer. What is the additive inverse of this number over here? So again, we do have the same thing, but at this point, we do have inverse. So what was additive inverse means that I have to find a number that if I add it plus this one, I'm going to have 0 as my answer. So that number is -8. Simple as that. So let's solve this question. Again, we are going to use the first one, the commutative property, commutative property. So it's going to be 3x plus 6 is equals to 21. I'm going to leave this question And when some kind of we had the second module, and when you had that one, you can come back again to answer this question. For some of you know something about it, you can answer it, and after that put it on the comment down below. So at the end, use the multiplicative inverse to solve this one. So again, this question is going to be considered as the next part. We talked about different kind of parts. Again, we had it from the module 1 of the math foundation. Try to again reread all of those stuff, try to learn it completely, solve all of the question. And after that, if you have anything, you can comment down below. You can just kind of send me an email or something. And if I see that there are so many people that need more help, I can make more practice some kind of question. But stay with me with some kind of next module. I will have it for you soon. Have yourself a great day, night, whatever. See you around.